Good afternoon, everyone. Thank you for joining. I hope you had a good Memorial Day and your weekend was excellent. Looking forward to hanging out with you today, and I'm looking forward to your questions. And feel free to ask as many questions as you want as we go through this session. We're going to have mostly second grade all the way through seventh grade today. And if there's any topic that is of interest to you, please go ahead and ask so that we may be able to attend to your needs. And I'll wait for a few more people to show up and then we can get started. I just want to remind you all that as part of this summer, to avoid knowledge loss, we're going to be offering some sessions. They're customized sessions. We are offering sessions in math. We will also be offering sessions in science. And as the demand, and based on the demand, we may have multiple sessions per week. So just ask us some more information about that. If you need more information, feel free to ask us, and we'll be glad to get back with you and enroll you in such sessions. We'll be having sessions that are group sessions, or if you prefer an individualized session, we'll go ahead and ask about that as well, and we'll be glad to serve you. Our goal is to make sure that if you were not able to finish your curriculum during the school year, you have an avenue for that. And if you want to prepare for the next school year, we also can help you with that. So thank you, and always want to thank you for your support, because it's you guys coming here and learning with me that makes this worthwhile. Thank you. Hello, Simisola. How are you? Lillian, good afternoon. How are you doing? So we'll wait for maybe one minute or so and get some more people to show up, and then we'll go ahead and start. So for those that are joining for the first time, you're welcome. If you're a regular, thank you for your support. And I'm going to go to the question that we're going to start with, and then you can go ahead and attempt it. The approach that we'd like to use here is we have the question out there, students get to try it, or the viewers get to try it out, and then they send us answers, and then we just work together as a group to solve them together. All right. Good afternoon, Jaden. So we're going to be looking at place value and estimating sums. It's for second to third graders. Always remember that if you have questions along the way, just go ahead and ask. If there's something that we're doing that you're not very clear on, also feel free to ask. There will be no problem addressing them. Good afternoon, Koto. Thank you for joining. Meanwhile, are you all on vacation yet? I know some schools are already on vacation, but are you all on vacation? Okay, Simi, I'm sure you'll be probably in about a week or so, right? 1 or 2 more weeks. It doesn't feel like a vacation. Yeah, I can relate. I can understand that. All right, so let's start with our first question. So Reagan High School, Bush High School, and Fulbright High School reported the number of students in their graduating classes as 587, 947, and 635. Estimate the total number of students in the graduating class of these schools to the nearest 100. So we're estimating to the nearest 100. We're estimating the sums, the total number of students to the nearest 100. So Jaden seems to have an answer. Don't forget to estimate each of these numbers to the nearest 100. Do we have any second graders or third graders here, or anyone going to second grade or third grade next school year? Because this is for you as well. Okay, so let's get started with this question. So we have 587. 587. Actually, let me give some room because I want to. So 587, and we are trying to find the estimate to the nearest 100. So what we're going to do is we're going to actually round each of these numbers to the nearest 100 and then add them. So let's go ahead. So your 100, this is your ones right here, this is your tens, and this is your hundreds right here. And this is the digit that we're interested in. So what we're going to do is we're going to go to the right. Remember, we have this heel right here. Anything from 0, 1, 2, 3, 4, then 5, 6, 7, 8, 9. So if you're on the left side of the heel, the number does not get increased. If you're at the top of the heel to the right side of the heel, then the number gets increased. So in this case, we have 8. 8 is the next digit to the right. We can see that 8 is on the right side of the heel. So that means that this 5 will be increased. So we're going to have 6, and then we replace every other digit with zeros. And then the next one is 947. 947. This is the digit in the 100th place. So the reason why I have this example here is I don't want you to fall for the trap of going for the 7. Remember, you always go to the digit to the right of the place value that you are interested in. And you can see here that it's a 4. So this is going to give you, because it's a 4, you can see on the heel is to the left of 5. So you're going to see that that number doesn't change, and we replace all the other digits with 0. And then we have 635. And in this case, we're looking at 6. We go to the right, we have 3. 3 is not up to 5, so we're going to leave 6 unchanged and then replace the digits to the right with zeros. So now we have 600, 900, and then 600. We're going to add this up. So we add zeros here, we have zeros here, and then 6 plus 9, we have 15 plus 6, we have 21. So the idea here is for you to estimate each of the numbers first, is to rather round each of the numbers first and then estimate the numbers. And it depends on how you read the question. Some students will actually go ahead and add all the numbers first and then round at the end. But what I'm trying to get here is actually for you to round each number first and then add them up, so you don't have to do that at the end. Are there any questions? Any questions? Okay, if there are no questions, we'll go over to the next question. So we're looking at counting money, and this is a word problem for 3rd to 4th graders. So Tom has 2 quarters, 4 dimes, 3 nickels, and 4 pennies. Rick has 1 quarter, 5 dimes, 2 nickels, and 6 pennies. Harry has 3 quarters and 5 nickels. What are the values of these coins, and whose coins have the greatest value? So which of these would have coins with the greatest value? Okay, so let's proceed. So let's look at Tom. We have Tom here. And then we're going to have Rick right here, and the last person is Harry. And so for Tom, we have 2 quarters, that is going to be 50 cents. 4 dimes, that is going to be 40 cents. 3 nickels is going to give you 15 cents, and then 4 pennies will give you 4 cents. So we're going to add all of this together. And then for Rick, we have 1 quarter, so that's going to be 25 cents. We have 5 dimes, we have 50 cents. 2 nickels, we have 10 cents, and then 6 pennies, we have 6 cents. Then we're going to add all of this together. And then for Harry, we have 3 quarters, that's 75 cents. 5 nickels, we have 25 cents. So now we want to find out the value of each of these coins. So let's go ahead and add all of this together. So we have 5 plus 4, we have 9. And then 5 plus 4 here, we have 9 plus 1, we have 10, so 109 cents. Then we have 5 plus 0 plus 6, we have 11. So we write 1 here, bring 1 up here. 1 plus 2, 3. Plus 5, 8. Plus 1, 9. So we have 91 cents here. And then here we have 5 plus 5, 10. We bring 1 up here. 7 plus 2, 9 plus 1, 10. So this is 100 cents. So whose coins have the greatest value? Now you can compare all these 3, and you see that you have different 3 values: 109 cents, 91 cents, and 100 cents. So which of these has the greatest value is going to be this one, 109 cents, and it belongs to Tom. So that's what you're going to do with this question. All right, any questions on this? So we can go to the next question. I'll go ahead to the next question. If you have any questions, feel free to ask as we go along. Now we're going to convert this number, this fraction, to a decimal, and we're going to round the decimal to the nearest thousandth. So we're going to convert to a decimal. We have fractions to decimals, and we're going to round it to the nearest thousandth. Okay. All right, let's see if we get any responses on this. I want to also remind you that for the summer, we're going to be offering some programs, and the programs are geared to students that want to prepare for the next year, and also for students that may be in their current year but don't feel like they covered everything. I know that's quite common actually. A lot of students did not cover all the topics that they had to cover for the school year. So we want to use this as an opportunity during this summer so that you don't forget everything you've learned and you don't feel at a disadvantage for the next school year. So we're going to do a lot of work from, I believe it's going to be about middle of June to the end of July. We'll be working with students from elementary all the way to 12th grade. And if you want more details on this, feel free to reach out to us. At the end, I'll post all the contact details for you as well. It would be at 2 o'clock, where the free sessions that we're having, the time isn't going to change, but we're going to have additional sessions for students that want more specialized help. So if you are, for example, going into 6th grade, and it will be a group session that will only be 6th graders. So like if you look at our session right now, we have 2nd graders all the way through to 7th graders. But the way that will be structured in the summer is we'll have time to just focus on one grade and one subject. So 6th grade math, If it's pre-AP or academic, we'll focus on just topics that are relevant to 6th graders. Thanks for the question. All right, so let's go ahead and solve this together. So we're going to convert 5/8 to a decimal. I want you to remember that there are 3 types of decimals, but the ones that we care about most would be repeating and terminating. So in this case, we're going to see whether it's a terminating decimal or a repeating decimal. First thing we're going to do is we have 5/18. So remember that 5 is your dividend. So that means it's going to be inside of your long division sign. And 18, which is your denominator, is your divisor. Okay, so this is going to give us 18 here. We have 5. So now, how many groups of 18 can you get in 5? Because 5 is less than 18, that answer is going to be 0. So we're going to multiply 0 by 18. That's going to give us 0. We subtract. We now have 5. So we're back to 5/18, 5 divided by 18. And we can now introduce our decimal. And because we introduced that decimal, we now have a license to add 0 here. So how many groups of 18 can you find in 50? So let's go ahead. 18 multiplied by 1 is 18. 18 multiplied by 2 is 36. 18 multiplied by 3 is 54. Let's go one more. 18 multiplied by 4 is 72. So here we have 50. 50 is less than 54. So we're going to go with 2 as our divisor, as our quotient rather. So 2 multiplied by 18, we have 36. Now we can subtract this. We'll get 4 here and then 1. And 14 is less than 18. So we can now add another 0 here. And we want to find out what you're going to get for 140 divided by 18. So how many groups of 18 can you find in 140? So it looks like we need to do some more work here. 18 multiplied by 5, that is going to be 90. 18 multiplied by 6, 108. 18 multiplied by 7, 126. 18 multiplied by 8, 144. So 144 is greater than 140, so we're going to go with 7. 7 multiplied by 18, we have 126. And then we subtract again, we have 4, we have 1 here. So we're going to bring a 0 up here, attach a 0 to 14. So 140 divided by 18, we have 7. 7 multiplied by 18, we have 126. And you can see that we're going to have a consistent pattern. And this is going to give you another 7 right here, 126. So it goes on forever. So this is what we call a non-terminating, which means it doesn't end. If we continue to go till forever, we'll still keep getting 7s. So this is non-terminating, and this is recurring decimal, or you can call it repeating. So this is a non-terminating recurring decimal, which simply means the decimal doesn't end, but when you continue to go, you have a consistent pattern. You have the same number continue to repeat itself. So you can see here that it's 0.277. If we continue, we'll still have a lot of 7s. So now we want to round it to the nearest 1,000. So let's look at our decimal. So we have 0.27777. All right, so this is our 10th. This is our 10th. This is our 100th. This is our 1,000th. Okay, so this is our 1,000. So this is the place value that we're actually interested in. So we're going to go look to the right, and we have a 7 there as well. And it's going to follow the same methodology, the same method that we used earlier. So it's 0, 1, 2, 3, 4, and then from the top of the hill, 5, 6, 7, 8, 9. So we can see here that we have 7 to the right. Because 7 is on the other side of the hill, we can now increase the number here. And so we're now going to have 0.278. Are there any questions? Does this make sense to you all? So this is 0.278. The first thing you're going to do is find out, so the thousandth means you have 3 digits after the decimal. So I like to go one more after that, which is one more. Some may go more than one, but you don't need to go more than one actually. So here we got to about 5 decimal digits. So 5 digits after the decimal place. And then you focus on the 3rd digit after the decimal, but then to do that you look to the 4th one and see whether you're going to increase the 3rd or leave the 3rd the same way it is. In this case we have a 7 to the right, which is greater than 5, and so we're going to increase 7 to 8. Okay, I'm going to be uploading a video on this probably by the end of the day today, so you should get some additional questions that you can work with. All right, let's go to the next one. So for 6th and 7th graders, we have a bag of marbles is found to have 6 blue marbles, 9 red marbles, 5 green marbles, and 4 black marbles. A marble is selected at random. What is the probability that the marble selected is not black or green? What is the probability that the marble selected is not black or green? What is the probability that the marble selected is not black or green? So remember what probability is. Probability is the chance that something happens. Is the likelihood, or is the ability for something to happen. So it's probable. Can this happen or can it not happen? So in this case, we're asking, what is the chance that if I select a marble from this bag of marbles, that it's not going to be a black marble and it's not going to be a green marble? So that's what we are going to be looking at here. The first thing you want to do when you have a problem like this is to find out how many marbles you have in the bag altogether. How many marbles do you have in the bag altogether? So total number of marbles is going to be 6 plus 9 plus 5 plus 4. So we have 6 plus 9 is 15, 15 plus 5 is 20, 20 plus 4 is 24. So now we have 24 marbles in this bag. Now we want to find out what is the probability that the marble selected is not black. So let's look for not black, not green. So I'm going to just cross out black right here. Where is the green? I'm going to cross out green here. So now we know that there are only 15 marbles that are not green. So number of marbles not black or green is going to be equal to 6 plus 9, which is equal to 15. So the probability, let's call this the event. The event is number of marbles that are not black or green. So the probability that we will select a marble that is not black or that is not green is going to be 15 divided by 24. And here's the explanation for that. We want to find out the number that satisfies what we're looking for. So we have 6 plus 9 because we have 6 blue and 9 red. So that's 15 marbles that are not black and that are not green. And then we want to always remember that we have a total number of marbles that is 24. And so our probability is the chance that we select what we have divided by the total number of chances that we have. So this is going to be 15 divided by 3, 24 divided by 3, and then you have 5 over 8. So the probability that we select a marble from this bag of marbles that is not black and that is not green is going to be 5 over 8. Any questions? Everyone is quiet today. Seems like a quiet day. Any questions on this topic before we move on? All right. Let's go on to the next topic for our second and third graders. A local clothing store is donating masks to Rylander Elementary School for the 1st to 4th grade students. The first grade class gets 185 masks, the second grade class gets 218 masks, and the third grade gets 198 masks. If the clothing store gave the school 806 masks, how many did the 4th grade class receive? So we're looking at the local clothing store that is donating some masks. We know how many 1st, 2nd, and 3rd graders get, and we want to find out the number of masks for the 4th graders, knowing that they've been given a total of 806 masks. So remember that any of the questions that I put out here, anybody can answer them, even if you're not in 2nd or 3rd grade. Remember, it's an opportunity for you to refresh your knowledge. So if you're in 4th, 5th, 6th, 7th grade, you can go ahead and try to answer these questions as well. It's more about the participation. I'm sure we all learn from each other. So feel free to answer any question. Even if you're in 5th grade and you see a 7th grade question that you can answer, go ahead and answer. It's all part of the fun. Good afternoon, Abraham. All right. So let's give you a few more moments to try to answer this question, and then I'll go ahead and show you what to do. So we have 1st graders. We have 1st graders. So 1st grade class. 2nd grade. 3rd grade. So 1st grade has 185. 2nd grade has 218. 3rd grade has 198. Okay, 205 is Soko. Good afternoon. Okay, so we have an answer, 205. All right, so let's proceed with this question. So let's go ahead and find out how many we know that the school has received. We know for sure that the total number of masks that were given to the school is 806, but we also know that this is the number given to the different grades. So we have 218. Let's go ahead and add them. 218, we have 185, and then we have 198. So let's go ahead and add this together. So 8 plus 5 is 13. Okay, I see more answers. Good. Thank you for participating. 8 plus 5 is 13. 13 plus 8 is 21. So I'm going to put a 1 here and bring a 2 up here. 2 plus 1 is 3. 3 plus 8 is 11. 11 plus 9 is 20. So we have 0 here and bring 2 up here. 2 plus 2 is 4. 4 plus 1, 5. 5 plus 1, 6. So therefore we have 601 masks between the 1st, 2nd, and 3rd grades. We need to find out how many masks we're giving to the 4th graders. So we're going to go ahead and find out the total number that we were given, 806, and we subtract 601, which is the number of masks that we're giving to 1st, 2nd, and third graders. And so we go ahead and subtract. So we have 5 here, 0, 6 minus 1, 5, 0 minus 0, 0, 8 minus 6, we have 2. So fourth graders are going to get 205 masks. 205. Good job, good job. Thank you, thank you. All right. So here we're looking at customary units, fourth graders and fifth graders. So the question goes that Noah planted sunflower seeds in his garden in November. In January, the plant had grown to 3 feet and 9 inches. In February, the plant grew another 2 feet and 4 inches. In March, the plant grew another 4 feet and 4 inches. If he trimmed the plant 1 foot 3 inches in April, how tall is the sunflower plant now? So everyone is free to attempt this. What I'm trying to do here is I want to check your understanding of adding customary units. Also, you're going to be doing some conversion. So I want to see how you're going to manipulate that. Nine foot 5 inches. Okay. Let's give everyone a chance to try, make an attempt at this, and then we'll solve it together in a few moments. If you have not subscribed to the YouTube channel, please go ahead and subscribe and share with your friends as well. Share with your older siblings, because on Thursday we're going to be having sessions for them, for 8th graders all the way through 12th graders. And actually, if you have any siblings in college, maybe the first year of college or the second year, and they need help with math, invite them to come join, and we'll be able to help them as well. And want you to also remember that as I do these sessions with you, I identify topics that are a struggle, I'll go ahead and create a video for that. And when you subscribe, you will know when the video is ready, and then you can actually watch it and continue to improve your math. So I see 3 different answers. Okay, all right. Okay, let's go ahead and walk through this together. So we have, I'm going to just underline the lengths that we have. So the plant grew to 3 feet 9 inches. In February, the plant grew another 2 feet 4 inches. In March, it grew another 4 feet 4 inches. And then he trimmed 1 foot 3 inches in April. So what I'm going to do here, just as a practice, is I'm going to do a plus minus. A plus is going to be growth, and then the minus is going to be for the trims. So we have 3 feet 9 inches, and then we have 2 feet 4 inches, and then we have 4 feet 4 inches, and then we have a trim of 1 foot 3 inches. So now we're going to add up all the growths. On the plus side, we're going to add everything together, and then we're going to subtract the length on the right hand side. So let's go ahead and do that. So I'm going to just do something like this: feet and then inches, just as columns here. So I have 3 here, and I have 9 here. I have 2 here, and I have 4. I have 4 here, and I have 4. So what I'm going to do now is I'm going to add all the inches together. So let me write the inches here. 9 plus 4 is 13. 13 plus 4 is 17, so I'm just going to write 17 here. 3 plus 2 is 5, 5 plus 4 is 9. And then I need to cut off 1 foot and 3 inches, so minus 1 foot and 0.3 inches. So when we subtract, we have 14 here, and then we have 8. Now what we need to do is remember that your inches are always going to be 0 to 12. When you get to 12, you have 1 foot. So now we're going to convert 14 inches to feet. So what we're going to now do, to convert 14 inches to feet, we're going to divide by 12 because there are 12 inches in 1 foot. So we divide 14 by 12. So we have one group here, 1 multiplied by 12 is 12, and we subtract, we have a remainder of 2. So what this means is that 14, let me get some space here. So 14 inches is going to be the same as 1 foot, 2 inches. So now we're going to add that to, so 8 feet, 14 inches is going to be 8 feet plus 1, let me put a T here, plus 1 foot and 2 inches. So now you're going to have 9 feet and 2 inches. If we were using our table here, so if I said something like foot and then inches, so I'm going to have 8 and 0, 1 and 2 here. So that's going to give you 9 feet and 2 inches. So that's another way to do it. It depends on which way you prefer. All of them are going to get you to your right answer. Okay, good try. Everyone is good try. I like the way you're responding, so that's good. Just remember that if you get anything wrong, don't feel bad about it. You're here to learn. We're all going to learn from each other, so it's not that big a deal if you don't get it right. As long as when we're done solving the problem together, you have an understanding of how we get to the right answer. Okay, so we're back to our fractions. We're going to add and multiply today. We're going to add 4 over 5 and 3/4, and then we're going to multiply 3 1/2 and 3/8. So for the 2nd to 7th grade group, I've made a commitment that as much as possible, we will do fractions every day because I want to make sure that your understanding of fraction is not something that you're struggling with, because as you get further in your math classes, understanding fractions will be very important. So I got 2 1 over 10. Okay, so let's get this going. So we have 4 over 5 and 3 over 4. One thing you have to remember with fractions, especially when you're adding or subtracting, is that for you to add fractions, you have to have the same denominator. So we're going to, whenever you have fractions that don't have the same denominator, your first task is to make sure you can rewrite those fractions so they all have the same denominator. Okay, so 4 over 5 plus 3 over 4. So we have 5 and 4 here, so I'm just going to multiply them together. So that's going to give you 20. And so our new denominator needs to be 20. So 4 over 5, I'm going to multiply 5 by 4 and multiply 4 by 4 because we want to create equivalent fractions. So whatever you multiply your numerator by, you must multiply the denominator by the same number, just so they can stay the same. So this is going to give you 16 over 20. And then 3 over 4, we're going to multiply 4 by 5 and then multiply 3 by 5. So this is going to give us 15 over 20. So instead of 4 over 5 plus 3 over 4, we're going to use our new fractions, which is 16 over 20 plus 15 over 20. And now that we have the same denominator, we can always add the numerators together. So we have 20 and then 16 plus 15, which is going to give us 31 over 20. And then we can now convert this to mixed numbers because we have an improper fraction. So 31 divided by 20. How many groups of 20 in 31? We're going to have one group because 20 multiplied by 2 is 40 and 31 is less than 40. 1 multiplied by 20 is 20, so we subtract. We have a remainder of 11. So now, as a mixed number, this is going to give you 1. We're going to pick 1 here, which is your quotient. And then your remainder is your numerator here, and your denominator is your divisor. So this is going to give you 111 over 20. And then for the second one, you're saying 21 over 16. Okay, so let's see. Let's see what that's going to give us. We have 3.5. When you're multiplying, you want to have both of them as either proper fractions or improper. You cannot have a mixed number. If you have a mixed number, convert it to an improper fraction first. So you're going to have, so 3.5 as an improper fraction is going to be 3 multiplied by 2, 6, plus 1 over 2, which is 7 over 2. So we now have 7 over 2 multiplied by 3 over 8. And with multiplication, you can multiply across. That always works. Multiplication and division, you do not have to have the same denominators for you to work with them. You can have different denominators. Only addition and subtraction require you to have the same denominator. So 7 multiplied by 3, we have 21. 2 multiplied by 8, we have 16. Great job, great job. 17 over 8. Take a look at that again. So 21 over 16. Okay, so we're at 21 over 16. And now we're going to convert this to a mixed number. So 21 divided by 16. How many groups of 16 in 21? We're going to have 1. 1 multiplied by 16, we have 16. We subtract and we have 5. So we have a remainder of 5. So this is going to be the same as 1, which is this number right here. And then our remainder is 5, and our denominator is 16 because that's also our divisor. So 1, 5 over 16. So thank you for participating on this topic. And let's go ahead to the next question if there are no questions. So every week we're going to, on Tuesdays every week, we're going to work on fractions. I want to make sure that you get very comfortable working with fractions. Okay, last week we had this topic and I noticed that some people needed additional help and needed more questions. So I thought to bring that into this session today. We're going to convert 3.5 gallons to quarts, and we're going to convert 120 inches to yards. Remember, anyone can attempt this. You don't have to be in 4th or 5th grade. If you're in 2nd grade and you know how to do this, feel free, enjoy it. So let's see, let me give you some, I know in your schools they probably give you a chart with all these measures. So it's going to be 4 quarts in a gallon. And okay, we'll look at this together. So we have, so Simi will look at this for sure. So we have 4 quarts in a gallon. And we have 12 inches in 1 foot. We have 3 feet in 1 yard. 3.3 yards. Okay. All right. So let's take some time to go through this so that those who are not very familiar with it will get some help. So we have 1 gallon here. 1 gallon is going to give me 4 quarts. Now I need to find out how many quarts are going to be in 3.5 gallons. So when you do it this way, so what I want you to always remember is whenever you're going from the larger quantity to the smaller quantity, multiply. Whenever you're going from the smaller quantity to the larger quantity, divide. So that's the trick here. So we're going from our larger, so remember I said 4 quarts make 1 gallon, which means the gallon is bigger than the quart. So therefore, we're going from our larger quantity to a smaller quantity, so we're going to multiply. So this is going to be 3.5 multiplied by 4. And we're going to use all our rules of fractions. And so we convert 3.5 to an improper fraction. So that is going to be 7 over 2, which is 3 multiplied by 2 plus 1 over 2. So that's going to give you 7 over 2. And then we're going to write 4 also as an improper fraction, which simply means it will have a denominator of 1. And now we can multiply across. So 7 multiplied by 4 is 28. 28 divided by 2, this is going to give you 14. Alternatively, or likewise, you can say 7 over 2 multiplied by 4 over 1. And you can divide 2 by itself. 1 divide 4 by 2, you have 2. 7 multiplied by 2, you have 14. So this is going to be 14 quarts. Does this make sense? For those that need help with this, does this help? So just remember the method. The method is if you're going from a larger quantity to a smaller quantity, you multiply. If you're going from a smaller to a larger, you're going to divide. And I'm going to show that to you in this second example. So we have 12 inches in 1 foot, and we have 3 feet in 1 yard. So how many inches are there going to be in a yard? Remember, we're going from a smaller to a larger, so we're going to multiply. So therefore, we have 36 inches in 1 yard. And then we want to find out how many yards they're going to be in 120 inches. So remember, I said if we are going from the smaller to the larger, we're going to divide. So I'm just going to go ahead and divide 120 by 36. You have a choice here of using long division, but you can just divide this way as well. So we can divide this by 12 because we know that if you know your 12 times table, so this is going to give you 10 over 3. And if you don't want to go with 12, you can actually go with 2 until you get to your destination. So this is going to be 10 over 3. I see some are using decimal, which is fine. So you can also convert 10 over 3 to you can convert it to a fraction. I will just make it a mixed number. So 10 divided by 3, we have 3. 3 multiplied by 3, we have 9. We subtract and we have a remainder of 1. So this is going to be the same as 3, which is this number here. This is your whole number. Anytime you're dividing, this is going to be your whole number, which is also known as your quotient. And then your remainder is 1. And then your divisor is your denominator, which is 1 over 3 yards. So this is the solution to that problem. Okay, we have one more question. I think it's for 6th and 7th graders before we go over to our puzzles for the day. We want to find the slope. Okay, the slope of a line that joins, an error here. The slope of a line that joins points 2k and s negative 3 is 2/3. What are the values of s and k? If you have any questions about anything we've done so far, please feel free to let me know. I noticed that on the last question, I can see that there's some understanding there. So if you have any questions, feel free to ask. Won't be a problem. All right, so for 6th and 7th graders, 7th graders can do this as well. But if you can, anyone that can do it, feel free to go ahead and attempt it. So the slope of a line that joins the points 2k and s negative 3 is 2/3. What are the values of s and k? What are the values of s and k? Remember what your slope is? Your slope is your rise over run, and this translates to y2 minus y1 over x2 minus x1. If you're just joining us, feel free, please subscribe to the channel so that whenever we post videos, you'll get a notification. Whenever we're about to start these free sessions online, you'll also get a notification. And whatever else we're trying to do on our channel, you'll be notified and you'll be kept up to date. So please subscribe and share with your friends as well. We'll be posting things frequently during the summer to keep you all engaged. Okay, so let's go ahead and look at what this question is about. So we have 2k, that's our first point. The second point is s negative 3. So I have a habit, and the habit I think is a good habit you should develop is, especially when you're learning, I'm going to put an x1, y1 here, x2, y2. So now I'm going to substitute these values into my slope. Remember that the slope, as I showed you here, is y2 minus y1, y2 minus y1 over x2 minus x1. So now we're going to substitute our values. y2 is negative 3, y1 is k, divided by x2 rather, which is s, and then x1 minus 2. So therefore, negative 3 minus k over s minus 2 is going to be 2/3. So now we want to find out the values of s and k. So I'm going to pay attention to the numerator and the denominator and create some equations here. So negative 3 minus k is equal to 2. That's the first equation. So let's go ahead and solve that. I'm going to add 3 to both sides. And that's going to give me negative k is equal to 5. And then we divide both sides by negative 1. And then we have k is equal to negative 5. Then the second one, we have s minus 2 equal to 3. And therefore, we add 2 to both sides. And so s is equal to 5. So therefore, we have our values for k and s. So k is equal to negative 5, s equal to 5. So our points are going to be 2, negative 5, and 5, negative 3. So those are going to be the points that will give you a slope of 2/3. Are there any questions on this? If you want more examples, just go to our channel. There are going to be several examples of this type of questions. There are a lot of questions on slope, and we'll have a playlist that would allow you to see all the stuff related to this topic. It's under coordinate geometry, and I think there's also the Algebra 1 playlist. You can take a look at that as well. And if you want us to do more questions like this, just let me know. We'll do that next week as well. Okay, so let's go ahead to our puzzles. So here's the first puzzle. We have 2 of them. First puzzle, we have upside down A, 4 upside down A2, and then period 2 is equal to 4. So what is the value of 24 upside down A3 and then closed circle 6? So what is the value of 24 upside down A3 multiplied by 6. Let me give you a hint. This represents I'll give you a hint. This represents division. That's your hint, and that should give you everything you need. So the upside down A is a division. (46). Let me see. How did you get 46? Could that be a multiplication error? But you're very close though. Very, very close. Shewanu, you're very close. 12. Let's see. How did you come up with that? 48. Okay. That sounds close. That sounds good. 14. All right, everyone is participating. That's a good thing. All right, since we have so many people participating, let's go ahead and let me show you what this is. This is division, this is multiplication. 4 divided by 2 is 2 multiplied by 2, 4. 15 divided by 5 is 3. 3 multiplied by 3, 9. 6 divided by 3, we have 2. 2 multiplied by 4, we have 8. 12 divided by 6, 2. Multiplied by 5, we have 10. And good. 24 divided by 3, 8. 8 multiplied by 6, we have 48. So good job, everyone. We have one more puzzle. This one is actually kind of interesting. Let me see what you're able to come up with in the first minute, and then I'll give you a hint if you haven't come up with anything. Yes, that was the multiplication error. (15, 17). Very. Wow, that's good. That is good. All right. Okay, that's good. I like that. Good attempt. So what we have here is 4 plus 3, we have 7. 7 plus 3, we have 10. And then we just multiply this by 2. Multiply this by 2. Multiply this by 2. And then we have the number on the right here. Then what we're going to do here is we're going to add 5 here. And so you have 9. 9 plus 2 is 11. 7 plus 5, we have 12. 12 plus 2, we have 14. 10 plus 5, we have 15. And then 15 plus 2, we have 17. So very good work. Very good job, everyone. I hope this was helpful and useful to you. And look forward to our time next week. If you feel like you want to join, find out what the 8th to 12th graders are doing, feel free to join us on Thursday. It's going to be a fun time. And remember that this summer we're going to still have our sessions from 1 to 2 p.m. Central Standard Time on Tuesdays and Thursdays. And we'll also have a different set of sessions that are going to be focused on your specific grade. If you look at our sessions, the session we had today had second graders all the way through to 7th graders. But in our summer program, you're going to have second graders separate from third graders and so on and so forth, so that we can focus on the topics that address your specific need. We'll be helping you review what you've done in your current grade and also help prepare you for the next grade over the summer, so that when you get started in August or September, depends on where you are, what state you are in, you'll be ready, and whatever happened with the online school this semester will not have affected you in any negative way. So I look forward to your time. Feel free to contact us in any of these ways, our email, our website, and then phone number, and we'll be glad to reach out to you and continue to connect with you. If you haven't subscribed, please remember to subscribe so you can get notification on anything that comes up. And have a wonderful day. Be blessed, and look forward to hanging out with you on Thursday for those that choose to come, and then next week as well for those that would rather stick with their own schedule. Thank you, and God bless.